Hey there. Anybody here care about security? Okay, good. 2 people do. That's good to hear. I'm sure that a few more do too. I'm going to talk about that, and I'm going to talk about how I want to address pretty much the big picture, big thing in the room in terms of how we actually execute on security. Now, this talk is about non-product research. And in fact, it's open source research, so y'all can party on and jump in on it and participate. I would love it if you do. And I'll give you a link at the end. So any forward-looking statements in here are about that research, not about products. We also would love to hear feedback after the session. But let's dive in and have a session first. I'm going to talk about why there are so many security breaches, why they actually happen. I'm going to talk about the principles we used to design a system that we call the Access Manager, and then give some examples. The fact is that the vast majority of data breaches are due to simple misconfiguration. There are studies which indicate that 80% of the large data breaches are due to simple misconfiguration. That's pretty stunning. And nearly every large enterprise has had a breach in any given year. That means like 80% of us are idiots? No, what I think that means is that the security systems that we have today are, by definition, not very usable. They have a problem because users are making a lot of mistakes. And so to fix that, we need some design principles that can guide how we build security systems. The design principles that I've chosen for the Access Manager are that we have to make everything extraordinarily simple. Simple so that people can tell what they're doing. Simple so that people can understand the context they live in. We also made this hierarchical, and not in the sense that it's inevitable, but in a sense that it's good to reflect the organizational structure that our users are embedded in. If we reflect that structure and they have policies that reflect that structure, then we can mirror that reality in our system. And thirdly, and this is an unusual thing, we have taken the system and simplified it to an extreme, which means it cannot express certain complex properties. We can, however, explain those and assert those properties in mathematical forms that people can select from a catalog of templates. And then we can then verify that those properties still hold in a way that virtually no other security system can do. And we can do that continuously every time anybody makes a change. Not only do we help people do the right thing and see that they're doing the right thing, we help them check their work. Now, besides these design principles, we've felt that there are a few use cases where delegation matters. We need to be able to delegate authority in limited ways, and we need to plug in authorization, identity, and enforcement mechanisms. But aside from that, those 3 principles and these 2 feature add-ons are all of the entire system. Let's talk about the details. We've arranged everything in a global namespace. Every data set gets a name. Every user gets a name. Every workload gets a name. We also have attributes in this namespace. And everything has a name. That lets us attach attributes to anything. Attributes to user. I work for HPE. I work in labs. Those are attributes I might have. I work on a particular project, another attribute. These attributes can then be inherited. We'll talk about inheritance as the last point. But the important point is all security statements can only be based on these attributes. We then compose permissions out of those attributes, and we inherit both attributes and permissions. So the global namespace looks kind of like this. At the top level, there's the AM scheme, that's the access manager. Below that, we can have directories that could reflect actual organizations, and those organizations can have people, workloads, attributes, data sets, and so on. Looks just like what you've seen before, right? That's the point. What you expect is what you find simple. Now remember, these are virtual names. There's no data here. These are names, places for the annotations, places for us to understand enough data so that we can create credentials and things like that. So the second point, attributes. Everything can have attributes. Permissions are then composed of attributes, and in fact, that's the only way the security can be expressed. So if I have HPE user, lab staff, access manager lead, access manager developer as my attributes, and some data has some HPE data and trusted as attributes, then we might write those attributes in that hierarchical form: access manager, HPE, attribute, metrics, trusted, that sort of thing. Again, pretty simple. Permissions are the next step. We create those out of attributes. So a particular workload might have some attributes, and it might have permissions. The read star means that that workload can only read trusted data. The view means only HPE users and HPE workloads can see the existence of that workload. Data similarly has permissions. And then inheritance is the last mechanism that we have. That tree that we saw of organizations and users before, we could put an attribute at the top level, say that this is the Acme Corporation of Roadrunner fame, and put that attribute on there, and we put a view permission on that. This says that only workloads and users that have the Acme attribute can even see the Acme organization. Then we inherit those downward so that there's a user in the lower left who inherits the attribute Acme. In fact, everything inherits that. And there's a data set on the right there, and it has a permission that says you have to have Acme to view it. And so that user can see that data. We don't know if they can read or write it yet, but that's how the inheritance works. It's that simple. One key property here, and this is crucial, is that once you inherit a permission, you can't uninherit it. This is the property that makes this simple to prove properties about, so that we can look only at the top level of Acme here. We can see that one permission that only Acme attribute holders can see Acme, and we know that that holds everywhere below that. We can do a 30-second audit of the policy, is Acme data visible to outsiders? We can look at that and we say, no. Furthermore, the Acme attribute is actually in the Acme attribute organization, so we know that nobody outside can manipulate that attribute. It's that simple, and that's how it should be. We should be able to accumulate these permissions in a way that makes it possible to prove certain correctness. Let's tell some stories. Suppose we have two organizations, Acme and Yoyodyne. We want to say Acme people see Acme data, Yoyodyne people see Yoyodyne data. Well, we do it very much like we saw in the previous slide with Acme, but now we add Yoyo. We have the single attribute on Acme and the single attribute on Yoyo. And the view permissions are just as before, but specialized. We're done. This multi-tenancy is now established. Acme cannot see Yoyodyne data, and Yoyodyne cannot see Acme data. It's that simple at the organizational level. Acme is safe because of the arguments we gave before, and everybody inherits it. Yoyo is safe for the exact same reasons. So here's another one, a trusted pipeline. In this scenario, we have trusted data and we have trusted workloads. And the idea is that we want to ensure that trusted data is only ever written by a trusted workload who operated only on trusted data. So it's a closed sort of family. It's a chain of trust. We can transform trusted data into other trusted data. To do that, we have a directory describing the pipeline. We put the attribute trusted on that. Everything below will inherit that. The workloads, the data will inherit the trusted attribute. And we have, can we move that slide back? I jumped ahead one time too quickly. We have a read star permission on the attribute or on the workload directory. That says that those workloads can only read trusted data. We have a write permission on the data directory that says only trusted applications can write to those data sets. So from here, it's a very small set of logic to say all of this trusted data is written only by trusted applications that are reading only trusted data. Make sense? Now, it also is true that we can embed this structure in the larger structure we had on the previous slide. We have a multi-tenant organization. Inside, they have a trusted pipeline. We know that the larger organization constraints do not interfere with the lower level constraints. They complement each other. And this helps with the fact that in any sort of security setting, you have to collaborate with people you don't even know in order to get a correct setting. The inheritance encodes the collaboration that you need to do. So here's another example, classified data. A classified application can read anything, but it can only write to data that is marked classified. And only classified workloads and users can read classified data. Well, this looks just like the previous example. This is an example of a template. At the top, we have the secret attribute, and we have a constraint on where secret classified applications can write at all. And we have constraint on who can read this. This is just the same as before, except duality between read and write. With agents, we have a slightly different situation. Suppose we have me as a user. I have rights to see my data, but not to see the directory that it's contained in. Molly here could be an agent, and she could be forwarding work to a service. The service has rights to see the directory, but not my data. If I can delegate first to Molly, and then she could delegate over just the attributes needed, then the service could see momentarily my data and the directory. But moments later, when somebody else makes a query, they could delegate other attributes so the system could see their data, but not mine. The way that that works is I have a bunch of attributes. I come in on the left. The agent has also some attributes, and it can talk to the service. I cannot talk to the service directly. The service can talk to the database or the directory, but the specific data can only be read if I delegate those attributes down in. So I'd like to extend an invitation right now. The point here is that we're trying to make a system that is tight, works against all kinds of data, works with all sorts of identity systems, and works with a very broad range of needs. That it works to secure data, works to secure endpoints, and cooperates if you need fancier controls by this delegation. It already hooks into S3. It hooks into the high-performance file system called Deos, and it already hooks into a variety of identity systems. What it doesn't do is hook into what you guys need. And I'd love to have you come work with me on this. Here's a link to the open source implementation of the Access Manager that we have now. It's a small service written in Go, small enough to audit, small enough to understand, powerful enough to solve real problems. And so we have just a few minutes left, which means I talked too fast. If you'd like me to slow down and would like to have a conversation about this, I'd be happy to step over to these tables over here, or we can walk back into the labs area right over behind this theater. And any questions you have, any applications you might have that might or might not fit for this, you can contribute just by telling me I'm wrong about something or how you have a fancy sort of need. So thank you very much. Don't forget to fill out the feedback.